Every company wants a unified view with all of their metrics, revenue, sales, logins, active users, conversion rate, page visits, everything in one single dashboard in one view. While this might sound easy on paper, in reality things can get pretty messy. And in this video, I will show how I'm solving this as a senior data analyst. The problem is not the metrics themselves. They are typically easy to calculate. The challenge is that they are normally spread across different tables or even different data sources, and you need to link them by common dimension. Most corporate teams solve this by either having a massive Excel sheet where they are manually picking the information from different dashboards, or they are building separate queries within the visualization tool and handling all the logic, join, relationships, etc. within your BI tool. This will mean, for example, pretty heavy DAX queries or a lot of messy blending in Lookers too. This is a major red flag. When you're putting business logic within the UI, things are getting very messy very fast. Also important is that if you're putting the logic there, the metrics are not really reusable. They are trapped within the dashboard or the semantic model, and it's also very hard to keep track of changes. For example, versionizing and using Git with a SQL file is super easy, with a dashboard not so. To avoid all the messy complexity within the BI tool, we will lift all the complex data layering to a data pipeline, where we will build a reporting-based table where all the metrics will be pre-aggregated and calculated within the script itself. Thereafter, we will connect the BI to just only this. But before writing the code, we need to define two critical foundations. The first one is the time dimension. How do we want to report things? Typically, a daily level is the most convenient one, but if you're getting more high level, weekly or monthly might also be sufficient. The second one is relevant dimensions. How do the user want to slice the data? Typical dimensions here is like country, maybe product area, or something like that. Important here, keep the second one tight, because you don't want too many combination within your reporting dataset. So let's build the logic in SQL, and we will do this with a CTE, where we will split each of the subqueries and then we will join everything together in the end. What I will do here is I will join three different metrics together. We have customer calls in this table. We have call date, country, call ID, call length. We have a login table with number of users logging in per day. Looks similar, login date, country dimension as well. And we have an order table where we are tracking the orders, also looking similar. So we will take each of these three tables and bring them into the CTE, and in the end we will join them together. The first thing that we want to do is to build a base table with all the unique combinations that we want to report on. So for now we want to report on date and the country dimension, and we need to make a table that contains all these combinations. We will do that as the first step in the CTE, and we will say select report date, country, and we will generate a date array first of all, report date. And then we will make a cross join where we will include the countries that we are having. So in the dataset I have UK, Spain, Germany and France. So I will just type them here as normal strings. Now if I run this query, we will see that we are having each of the combinations for every day. So for example, the 1st of January we have France, Germany, Spain, UK, and then it's being repeated again. By this, we make sure that we're not having any gaps in our reporting table. Let's aggregate the first table. Let's start with the orders table. But here we want to do select. We will take order date, use the country. So this is the same dimensions. We have the time dimension and the country dimension. And thereafter, I will just make a count distinct on the order ID, grouped by 1 and 2. So this will be the first aggregation of the orders, and actually we can have a look on this. And this will be the orders aggregated table. In a similar way, we will build the login table. So here we will select login date. Here we will say the distinct user IDs. And you will see we're having the same structure in the logins as we're having in the orders table. And just go ahead with the final one, which will be the calls. Now we have three similar tables: calls aggregated, logins aggregated, and orders aggregated. The final step is to put these three together and join them onto our base table. So we will start with the base table, and we will get the report date and the country date from this table. Thereafter, will also important to handle the nulls. Just write COALESCE there, and we will say the total. Let's look at the first one, the orders. So o.orders 0 as orders. Here I will make the first left join on b.report date and b country equals. Second one is to get the data from the logins. So here we have unique active users. And we will make a similar left join. We will take the logins aggregated here, and here we will write L and L. Let's take the final one, which is our calls. And we need the same left join here. We missed, we took the false date. For here, for sure, we need a login date instead of order date, and the same for the calls, we need the call date down here. But I think with this, we are done, and we can, let's also order it by country date. And if we're running this, you will see that we are having, now if we're running this, we will see that we are getting a clean table ready for reporting, where we have merged different data sources into just one table. And this single table is the one that you will just load into your BI tool, and from there on make all the reporting very easy without any need for any complex logic within your semantic layer or within the BI. The database has been doing all the heavy lifting, and if you're finding an error, you will just have to go inside the SQL and fix it. You don't need to dig around within your BI tool. And this is a perfect example of how you're building a sustainable data tool for your company or in your project. I'm Marcus, Senior Data Analyst, and hit subscribe if you want to see more videos and tutorials about real-world data analytics topics. Also, I've dropped all the CTE and some more links in the description. If you have any questions, feel free to ask them in the comments, and thank you for watching.